is readily available for every pin. And with identical origins in grids, the placement and the routing and the testability is going to be improved. Okay. And we can save off these as reuses if we want to with different software, depending on how your software names that. But again, it's a repeatability from circuit board to circuit board using a saved off reuse. So once we've built all these, we can now floor plan our board, and they will be more representative of the actual parts required. And unrouted connectivity, the rat's nest, would be minimized, reflecting just the greater description of the buses and circuit flow. And when you're going to name these groupings, you name them by their functional name. Don't call it U15. Call it, the FPGA or the CPU. And this way, when more than one person is reviewing it and you pick up the entire block of components, they understand its major function. And this helps in the understanding between an engineer and a layout person. This image shows a dense board that has been placed. And to show you the nature of very dense boards, let's say maybe 2,600 some individual components, or it's broken down into 114 little unions or groupings. Which would you prefer to place? Placing 2,600 individual entities can take weeks, but you can place 114 entities in an afternoon. And because I built them somewhat rectangular, they will fit in next to each other, playing the shell game. Now, when considering some placement strategies for RF circuitry, typically these types of circuits have very critical concerns for every facet of their development, especially with this sentence, the above placement determines routing. Okay, so the RF circuits typically seek an outer layer route strategy with important signals routed as transmission lines. Careful allocation and placement for clearance for coplanar waveguides are often required. So therefore, you're strategizing the amount of resources to route on the outside layers. Continuing our look at placement for RF circuitry, oftentimes RF placement will be collected into groups of circuits based on the amount of noise loss or gain that is allowed within each grouping. These are often placed into chambers for isolation purposes. These chambers are isolated in all dimensions on the board, both the X, Y, and the Z. The Z-axis contains emissions going on and off the board. We can control that with a shielding can or a housing, or the layer below it can and should be ground. So again, consider making groupings that you could possibly shield with a can. So we're back to our agenda page, whereby we're going to start looking at routing our board, the different phases of routing, and of course routing it again for different types such as high-speed digital or RF. So we'll probably look at a few more too. So considering some of the challenges of our circuits today and tomorrow, we'd looked at this before as speed and performance increase. There are certain things that it's going to mean to that person routing these signals. What it is the margin for error is significantly reduced. What cannot be tolerated with today's circuit, our timing margins cannot be exceeded. This is for signals and buses. There's a certain amount of length based on the rise time